When the Soviet Union collapsed, Cuba's economy was sent reeling, sparking the worst economic crisis in the nation's history. The then President Fidel Castro proclaimed that the revolution had to make a deal with the devil to survive. The revolution turned to foreign tourism in hopes of finding an economic jolt. Post-Franco, the Balearics are not so different, but it's not just hotels. This is Mallorca, and I printed out a little map from September last year of Airbnbs on the island. There's 13,885 Airbnb listings in Mallorca alone, and every one of those is a place that someone who works there can't live in. Over the whole of the Balearics, which includes Formentura, Mallorca and Ibiza, there's a shortage of 45,000 homes. This has led to a social and economic crisis. Mallorca is not for sale, they say as they parade down the street. There's also, as you know, a climate crisis. This isn't Mallorca, this is Almeria, which is down the bottom bit of Spain. And that's where your red peppers and your tomatoes and your cucumbers come from all year round. And they come from there because this thing you can see from outer space. It's not the Great Wall of China, you can see it from outer space. These are greenhouses on what is actually a desert. And in there, plastic sheets, 1 metre, 1.5 metres off the floor, held up on poles, are the thing that separates water from the sun. And flooded with water, we grow these water-rich vegetables like peppers and tomatoes, and an itinerant labour force from North Africa, basically indentured kind of slave labour from North Africa, comes and tends these vegetables for you. They're suffering from extreme desertification, and this is, it's not just using up Almeria's water table, it's using up the southern part of Spain's water table. I took this down, a photograph on the way down to the beach in Ibiza. Each one of these residences or Airbnbs or whatever they are benefits from an air conditioning unit to keep them cool. It might seem a bit unnecessary, but at 40 degrees centigrade, it's actually a life and death issue. Then there are imports. The tourism, the population of Ibiza is about 10, Mallorca's similarly, and there's hundreds of thousands of tons of food imported. Stuff's imported from the mainland to feed this burgeoning industry. So add to that, because of the climate crisis, because of the European Union membership, buildings in Spain since June 2020 have to be nearly zero energy buildings. This is broadly like the German passive house standard. We're talking about, I'll read them out, airtight construction, mechanical heat ventilation recovery, high levels of thermal inertia, we'll come to that, solar orientation, the opposite of ours where they don't want the sun, effective insulation, high quality windows, absence of thermal bridges, renewable energy inputs, local climate consideration. If we look at Mallorca, this is the Spanish regulations. If we look at Mallorca, I've added, my red pointer doesn't work because it's a TV, but you can see London on the end there. Mallorca's broadly the same as Valencia. It's a category B climate, so these are the regulations for thermal conductivity and so on. And I've put London's on the right, so we don't let in the current British building regulations, not passive house, but just the standard Part L. The insulation levels in walls and floors are higher, our roofs are definitely better insulated, our windows are better performing, our doors are better performing, and the floors between dwellings are better performing. But the regulations are probably sensible for the climate that they have there. And into this comes IBAVI. The Balearic Social Housing Institute, style IBAVI, has been building and operating low-cost housing in the Balearic Islands since 1986. Around 1,800 rental apartments already exist, and 900 more are now being built. For most of its buildings, IBAVI commissions independent architectural firms such as H Architectus, Tadea, Peris and Toral, Data AE, Lopez Riviera. And IBAVI's in-house architectural team also design buildings. In all these cases, they pay full fees. IBAVI's projects begin with a technique of resource mapping, which allows them to discover all available local resources, whether tangible or not. They're also the only social, apart from perhaps the books on Camden architects and LCC architects, they're the only state-funded social housing provider that gets an L Croquis about them, 219. They benefited from applying for and successfully winning a European grant to do research into sustainability. It's not normally given to housing projects, but they managed to make this proposal for the life reusing Posidonia. They got 754,000 euros from the life programme, and they did that to build, and they used it to build 14 social housing units on Formentera. And they developed this catalogue of research, which is a 144-page document. I've just selected a few pages from it to give you an idea, but it's downloadable somewhere from a website. So category C1s are local eco-friendly materials. That's the best. There's not transport costs, and the materials are doing their job. They considered them to be, I think, 100 kilometres, but because Formentera is a small island and quite a long way into the Mediterranean, they allowed Mallorca to count as local for them. The best things reusable local waste, we'll come on to that, eco-friendly products. We're moving kind of away from what we want to what we have to have for non-local eco-friendly products, and then recycled and optimized products. At this point, the Itong cellular concrete blocks are an example. And the key thing about the IBAVI approach is not just to build it, not just to build social housing. These cannot be done, there's no right to buy. No one can take these off the state. They're owned by the state. If you have enough salary to rent somewhere, you can go and rent somewhere. These are for people who need these spaces and would otherwise not have accommodation. They would have to live in small rooms with their parents or what you will, or pay an extortionate market rate because they're competing with the Germans who own all the property on Mallorca. These are the achieved rates. You'll see there they've got the insulation. It was natural material. We'll come to it. Similar broadly to fiberglass rolls in terms of the metre squared kilowatts. I've compared it with London regulations, current Part L. So the insulation's not as high performing. The walls are not as high performing, although very much high compared with the net zero regulations that we saw earlier. But I do notice that the windows at 1.1 are better than our building regulations window. In fact, 1.1 windows, that's passive house standard. And the thing that they've done is they've gone back and they've measured. They've measured, they know the data and they know what does work and what doesn't work in their theory. So to take one of these materials, Posidonia oceanica, or Neptune grass. This is an undersea saltwater plant which washes up when dead on beaches like this. And due to its chemical composition and content of phenolic compounds, sulfides and sulfites, there's no terrestrial predator that can destroy it. No fungus, mushrooms, termites, nothing. So it's there, it's ugly, the tourists don't want it on the beach. So what they do is they gather it up, they dry it, and they use it as roof insulation. And it's not limited to Mallorca. Here's a map of the Mediterranean, and in blue, they're the places that the Posidonia washes up on the beaches. Here they are installing it. It's been sun-dried, and then there's a timber frame, and the guys on site are hand tamping it down to form the insulation. As I said before, thermal capacity is broadly similar to fiberglass mat, which is pretty good. Another material, Mares. Now, you've probably seen this before, Mares. This is a quarry. This is a seafront quarry of this sandstone, which is about 50% of the underlying geology of Mallorca. You've probably seen it because you'll have seen Canlis, the Jornotsen house. So Maris, this building was constructed with the outer walls and columns in the Maris sandstone. They're a cavity wall construction. Then another local sandstone, Santiani, it's tighter textures used for sort of slightly waterproof surfaces like kitchen worktops and some interior walls. The main roof construction is vaulted tiles, which is, again, they were locally made, and all woodwork is the Madeira Norte, Mallorcan pine. And IBAVI described this building as their university. There isn't an architecture school on Mallorca, but they do have this Jornotsen house. So I was lucky enough to arrange for a student field trip to see the works of IBAVI, try and understand their ways of working. And the guy in the hat, I think because he's thin of hair, is Carlos, and he is the chief architect and the main researcher and a very, very persuasive speaker on this subject. And I'm going to initially show you one of his projects, one of IBAVI's own projects that he took us to see, and that's here. This is 8 dwellings, and you can see it's an infill site. It's by a railway line. You can see the vaults on the end, and we'll see why. Because in structure, it's 8 metre deep, double vaulted ground floor, and then a stone column and timber structure on top. And you can see very thick levels of insulation because it uses the Posidonia insulation and the Maris sandstone. There used to be 100 quarries for that sandstone on Mallorca, but now there's about 5. But because of the demand that IBAVI is putting in, some are reopening and a new generation of people are joining, and they're no longer just using tools from the 1950s. The solar shading is, we're not really allowed to do this here, but the solar shading is vegetation, and they use reclaimed timber for the shutters, and the idea is that the communal spaces in the Mediterranean, you sit outside in a summer's evening on a rocking chair and talk to people rather than inside sweating. We went around the site, and not in this but in the one next door, which I'm about to come to, I saw an air conditioning unit, and Carlos told me that they're not allowed air conditioning units, and they can be their contract can be terminated for having them, so he'd sort that out. They went on and built the 19 dwelling unit alongside. The railway line's at the top, the very small main road at the middle, and then the kind of small, you can't call it a town square, but it has that kind of function between the buildings. Unlike the 8 metre span of the first phase, there's a 13.5 metre depth here. The floors therefore span from the party wall to the party wall. You can see that the walls going across the plan, so they're short span timber floors between them. That frees up the facade to be just solar shading. And they use a sloping roof system based on the Menorcan system. On the right, they use the Majorcan system because the massive weight sits on the walls and that pins down the throw of the arches on the ground floor. Here they use the Menorcan system, which comes from Catalonia and is much thinner. That's where I found the air conditioning unit, by the way. There at the end, the apparent chimney, their ventilation extracts, and you can see the building in a very tight street achieves its solar shading through a deep facade. The details are what they are. They don't need to hide the fact it's roof tiles, they rather celebrate the fact it's roof tiles. This is a photo montage because the street's a bit narrow, so use the pin cushioning. But there you can see that the open spaces have external and internal spaces and allow a variety of uses and dwellings between them. Here's the elevation. At the back, it actually has a car park, and that's similar to a lot of other IBAVI projects because the local government regulations require they have parking, but no one actually gets a parking place, no one parks there, and the intention is to use it for a social function in the future or to build on it. There's the details, as you can see, thinner construction than the first phase of the development. but obviously thick because of the slight inefficiency in insulation. Here on two other IBAVI projects, you can see the way that they're developing a consistent language of materials. They say we don't want to learn every new material. Once we've found something that's right, we want to stick with it. On the left, this is a building by other architects. It's made of fet de terre blocks. These are soil. They're soil blocks. There's no firing in them. If you have a brick, you have to use petrochemical energy to make it. There's no way around it. Bricks are made at 1200 degrees centigrade. To make a fet de terre block, you press clay and then with some binders, and then you leave it to dry naturally. On the right, that's Morris sandstone. Both of them have flat brick arches. You can see they've cut the arch in the top left, pre-made in the fet de terre. So it's an arch, so it's strong. It's cut, so it's not going to collapse. It can do the span. No steel, no metal, no thermal conductivity issues. And on the right, the same cut out of stone. The joinery liner is local pine, largely reused from reclaimed buildings. I asked why they use rebar for the balcony guardings. Apparently, it's better quality than the standard steel. It's pre-rusted, and it gives a grip for the solar shading to hang on, or you dry your clothes on for natural ventilation. So this is not an IBAVI project, and I'm going to try and use the words of H. Architectus so I don't miss anything. On the plot, this is in the centre of Parma, New York's capital. On the plot, there was a building that we were obliged to demolish due to its non-compliance with urban planning regulations and its poor condition. There was no possibility of preserving it. It was a small, disused, three-storey school constructed with structural sandstone, that's the Mores, and concrete and ceramic ceilings. The project strategy is urban mining, where material resources come from the urban plot itself, resulting from the demolition of the pre-existing building. Once the demolition was completed and materials were selected, nearly all the rubble was repurposed according to material type. First, pieces of ceramic and concrete elements, 140 metres cubed, were poured into the foundation pits and walls of the semi-basement. Second, all the sandstone, about 160 square metres, was used to construct large blocks of cyclopean concrete with cement and lime mixed with recycled Morris stone, 40% of the block volume, composed of large cobbles up to 30 centimetres diameter, sandstone gravel and Picardis sand, which is also made from the Maris local sandstone. Each block was cut with a large disc saw from a 4 by 4 metre slab, and the stones reappeared on the faces of the blocks. So they took the materials to a quarry, and they used the quarry system. There's a diesel generator that powers that saw, but that's it. That's the quarry. That's it. And instead of making 3,000 different formers to make the blocks, they cut them into these standard sizes and then subcut them to make all the walls in the project. The blocks of the top floor, being less load-bearing, are made of 100% lime concrete, while the rest of the floors combine lime with cement. These blocks, approximately 135 centimetres long, 42 centimetres high, and with variable widths for each floor, 65, 54, 44 and 34 centimetres, were prefabricated once the demolition was completed before commencing the construction of the new building. This approach significantly reduced the construction duration. The blocks were attached were stacked to build load-bearing walls perpendicular to the street, supporting cross-laminated timber ceilings. On each floor, the walls reduce in thickness by 10 centimetres, allowing direct support of the timber floor panels, facilitating the speed of execution of the entire structure. The perpendicular to the main walls, so these are the main walls coming into the plan, and you can see them on the top in heavy black, perpendicular to the main walls, 13 centimetre thick partition walls, constructed with the same cyclopean concrete and resulting from cutting a 60 centimetre wide block into 4 13 centimetre sections. The structure of the entire building is bound together to the stair core and the elevator. The spatial organisation of the building responds to the structural system. The floor plan is organised with the stair core on the corner, providing access to a walkway in the interior garden, from where each apartment is accessed. All are through apartments except those on the semi-basement floor, which, like those on the attic floor, have half the depth of the typical floors and utilise 2 structural spans for each apartment. So all the apartments mid-floors, front to back, apartments in the basement, just on the courtyard, apartments on the top floor, inset. Each floor also has a communal area of laundry or lounge, etc. on the corner. The facade starkly displays the structural system. The vertical end walls of the prefabricated blocks, which decrease in height in each floor and support the timber floors. And you can see they've also followed the same material means on the interior. So this is an IBAVI project. It's out in the countryside, in Monges 21. You can see it's developed from the 8 unit that we saw at the start. In summer, the passive strategies are inertia, mass, and moisture comfort provided from the stone. Cross ventilation facing the prevailing breeze from the sea. The breeze is called embat, with the support of ceiling fans, sun protection through traditional wooden shades, and thermal insulation of 10 centimetres in the walls and 24 centimetres on the roof. And here you can see the windrows from Palma Airport, and you can see the orientation of the building. On the map it's the black one, and you can see the orientation is very much so that the breezes will go across the plan. And this embat wind is very consistent. It blows from the sea to the land, and it blows from the land to the sea because of the thermal issues of the Mediterranean and the land heating up in the sun. And they didn't just trust to look. They did computational models and so on. And I don't have a very good slide, a blurry slide, which is a screen grab, so I won't show you that. You'll also notice that the building is on the very south of the village, and for planning regulations, they can't build any further south, and that led to an interesting thing. They have a trombe wall on the south, so in the winter, a small cavity heats up, gets pretty hot, like 90 degrees centigrade in the sun, and then it goes through what's effectively a drain pipe to cupboards in the kitchens, which have the mechanical heat ventilation system. All that happens is a man turns up in April and turns that handle round, and he comes back in October and he turns it the other way. And that's the technology. That's the technology. And if you look at the end elevation, if I just click back, you see there's 1, 2, 3, 4, 5, 6 trombe bays, because each bay is piped to one dwelling. There's nothing clever. The cleverness is just making it work from what they have. This is the construction, and it looks superficially like the first project I saw you, but actually there's a lot less mass in it. The stones, which are straight out of the quarry, it's the standard size they cut them, are turned round to make deep piers, and those deep piers are used for things like the pantry, like the hot water tank, like the kitchen, and like the toilet. And there's a stack system of stones that stops that splaying out, and on top of it, the lightest weight of roof possible, which means that a flat roof would cost money, and the walls would have to hold it up. They have a sloping roof with insulation, with tiles, because they want to give the most they can to the most number of people with the least amount of wastage. It's built out of the materials of an old garage that were on the site, where they repaired cars. The plinth is entirely from that stone, the rest is reused, and it has a communal courtyard, which is shaded, gets a bit of evening sun, but otherwise is shaded. We were fortunate enough to be taken inside, because the middle one's not yet occupied, one of the 3 middle ones. So this is the view from the first floor, looking down, looking up, and then you see, for example, the bathroom. They only tile the shower because that's the place where it gets wet. There's no point tiling anywhere else. The screeded floor's fine. And this is a view on the right. I'm inside one of the bedroom units. It's got a flat ceiling, so you can put your storage on top. and on the left there's a kitchen, and you'll see the kitchen is very, very basic. It is that and that. So there's some very nice tiles, some are reclaimed, some are locally made. That's an induction hob. That's the stone bench. This is the small, more marble-like stone from the island, and that's all you get. And the reason it's all you get is because every time the tenants is changed, they had to spend €3,000 stripping out the kitchen, which was made out of melamine-faced chipboard, and putting it in a skip, and then getting another melamine-faced chipboard and putting it in for the next tenants. So here, you just get a slab and you put your fridge underneath it, or your washing machine. Bear in mind you don't need a tumble dryer because everything just dries hanging over the balcony. If you've got a big fridge freezer, it can go in with a boiler, which is where the mechanical heat ventilation recovery is. And there's an idea that these have a quality. So they don't want the buildings to last for 25 years, they want them to last for 100 years or more. You don't know what use they'll be. You can take all the pine out. There's no kind of hierarchy of rooms in there. You won't see sockets. That's because the conduit is cast in the floor slab and they chase just the bottom 150 mil out of the Morris, put the cable in and then just cement over it. That's the detail. Surface mounted socket otherwise. And there you can see my students in the space with Carlos explaining to us about how you cannot copy what they do. He does not suggest for a moment that you build an IBAVI building in London. He says, where are you from? And different people in the group are from different places. Someone's from Brazil. So, what did they build in Brazil with before the Industrial Revolution? Turns out it wasn't timber because they have a lot of insects that just eat through the buildings. And he went round and got the same from everybody. We've all got stuff. My answer was stone, because that's where I grew up, the limestone. In fact, Europe's biggest cement works, extracting lime from there. But elsewhere it was mud. You know, East Anglia, they're building with oak and soil, and there's no reason why they couldn't do that now. They're indigenous materials. So that concludes Mallorca, and now off to Ibiza. This is another project by architects other than IBAVI, Perez and Toral, and it's 43 social housing. And you might not like the Adobe appearance of it, but let's hear it out, shall we? So every room in the plan is democratic. They're all 12 metres squared. They're all 4 metres by 3 metres. And Perez and Torres think you can pretty much get anything in there, whether that's a staircase or a bathroom or an external space to dry your clothes. That leads to this sort of stripy plan. That might seem a bit mad, but it means that their structural system, which is clay earth blocks and thin concrete beams, can work because they're all a 3 metre span. And the regularity means it's easier for the builder to understand and construct. No complex ideas of this, that and the other. As the hierarchy of spaces is an equality of spaces. Here it is in its summer condition, and here it is in the winter. I'll have to lean forwards to read the numbers, but in the winter on the right and the summer on the left. So in the summer, we get heat rising up, drawing moisture out of central soil spaces which are connected to the earth below, and ventilating out of a greenhouse area where the sun is shaded, but pucker fans drive the air outside. These are mechanically controlled. And on the right, the winter condition, where it's 11.5 degrees, aren't they lucky, centigrade outside, but it manages to be 18 degrees inside without anyone spending any money on heating. The way that works is our clay blocks are covered with cork insulation and some glass block insulation. The bottom has got marble on, so we don't get damage. The solid wood door sets are married with ventilated grills, which are made out of local clay tiles. And that means that the air can be drawn in through the common parts, which are what they're made of. CLT block, wood, clay, walls, the handrail there is just a piece of steel. And they're drawn up and out into this high space. And rooms kind of less significant rooms ventilate into that space. This is in winter, because it was in the winter. The blinds, which are automatic, are down, the fan's not turning, and the vents are closed. And here, an external drying courtyard where you can go and hang your laundry without it being all over the facade of the building. And this is a view of the top of the stairs with the lime plaster. It's all breathable lime plaster on the right, which is how the stairs are finished on the verticals. And this is it under construction, and you can see the rather elegant beauty of the clay block. Nothing to it, no reinforcement, and the simple grid of concrete that does the floor structure and sits low bearing onto the fetted terra block. There's the odd concrete column, but basically it is the structural system for a building of that many floors. And then just around the corner, 24 public housing units that's not the postcode, that's the name of the architect. They're called 08014. If anyone speaks Spanish, you could say it. No. Ocho, whatever. Anyway, they're very nice and very hard-thinking architects. And they built this building using, at the time they built it, these extruded terracotta blocks were made in Mallorca, but the factory has since closed.
The previous architect, what was the name? The previous one?
Perez and Torres.
Perez and Torres.
Yeah. So here we see a building with some expression. It's 4 courtyards. You could just see in the previous slide that the courtyards have got greenhouses on top of them, and wrapped around each courtyard's typically 2 apartments. And you can see in the plans, which I can't really see, but hopefully you can, that you come in through, for example, a kitchen to a living room. There's corridor spaces which offer pleasant relax from the heat at certain times of the day, and then you come to bedrooms and so on. You'll see the bathrooms are on the facade, which means they're naturally ventilated, which means the moisture can be drawn outside locally rather than racked up through the building. And you see on the top right the same idea of the ventilated atrium in its summer and winter conditions. This project also uses the Posidonia, which is the seagrass. It's brought out. It's only harvested at certain times of the year because it protects the dune slack, but the tourists don't like it, so they're very glad to get rid of it, and it keeps on turning up. It's an almost limitless supply of insulation material. That's put out to dry in the sun. It's a one-man factory. It's a sheet of plastic and a man doing this, and then it's gathered up into the sort of bags that you carry things around at IKEA and dropped off into this grid of local timber. And then, interestingly, this block, they've used the terracotta blocks. They come in a number of sizes, not many, and they're extruding enough holes in them. But to increase the thermal mass, they fill the holes with the sand that they excavated from the site. So there was no way they could meet the thermal criteria without insulating the outside of the building. There was no way that they could meet the sound requirements without adding deadening plasterboards inside. But what they've done by persuading the contractor to tamp the admittedly very dry sand that it's sitting on into the blocks, they've achieved the outside of the building being the terracotta block and the inside of the building being the terracotta block. Useful for us in our colder climate, they have incorporated a layer of insulation in the cavity. So the outside is acting in some way as a rain screen, and the inside is acting with the thermal inertia enclosed with the block. The insulation is cotton recycled bats, which have a fungicide in them. And they've got a very thin layer over the top that seals the joints, makes them airtight and deals with permeability, air and moisture. Here it is. It's opposite the most disgusting array of hotels that you could possibly imagine. And it sits there as a sort of jewel in this sea of detritus. And then you can see the same usual IBAVI details of the most basic solar shade. The reason it sticks out is so the sunblind can hang out on it but the air can go up underneath, and the MBAT can then draw the air through the building, taking the hot with it and bringing in fresh air from outside, which is of course cooler than the air that's built up inside. And mechanical extract at the top, you can see there. And there it is on the street facade. The blocks that face us don't have fill, so they come out red. The blocks that are sideways to us do have fill, so they come out white. You can see the bathroom vent at the top, reused timber where possible. And there's a nice person who was an immigrant and is very, very happy with his dwelling, and happily left the door open for us so we could go inside. Unlike the local chap who shouted at me for making a noise. On the right you can see an open courtyard. The roots of the plants go down into the soil, so they wick up water. Post boxes, nothing more than it needs to be. There's a student hiding behind a column. This is that central space. It's a very wide photo, but you get the idea. And then this is a typical flat, in this case a ground floor flat. We saw the plans of the dwelling wrapping around the central courtyard, but with less private rooms. And there to finish, I wish I could read it, whoever wrote this thought it was an island, but Ibiza is actually just a bit of Ibiza. Social housing on the bit of Ibiza called Ibiza. And then he says largely plant and earth-based materials means embedded carbon is only, he gives a number which is very good, and then he gives a construction cost that's unbelievably cheap. And then he says rent is between 203 or 500? 500 euros a month, exclamation mark, exclamation mark.